Okay, so until now, you may have been told that you cannot take the square root of a negative number. Every number was positive after you squared it. This suggested that you could not take the square root of a negative number and expect to obtain anything sensible. Now, however, you will explore how to take the square root of a negative number, but it involves using a new number to do it. The new number, denoted I, is an imaginary number. So here's the definition of I. I is defined to be equal to the square root of negative 1. So I don't know if you want to bold it. It kind of seems like it's in the middle of something there. But so it uses common sense math along the way. It's not like you're learning new math here. It's just a new concept, right, with a new system. So for instance, I squared is the same thing as I times I. You see that? So then what is that actually equal to? Well, do you see if I have I, right? That would be the square root of, you might say, well, that's the same thing as negative 1 times the square root of negative 1, right? Now, maybe you don't actually know this, but if you were to square a square root, it just undoes it. For instance, if you have the square root of 4, and then I times it by the square root of 4, what do you actually get as your answer? You actually get 4. And the reason behind it is it undoes, like a square undoes a square root. So if I have the square root of negative 1 times the square root of negative 1, what do you think I get here as my answer? I get negative 1. So that's a huge concept for you. So you may want to write this down. So I equals the square root of negative 1, and I squared is equal to negative 1. So that's essentially the concept of the imaginary number here. So what do you think? What do you think then I to the power 3 would equal? Yes?
How can it become negative?
Well, that would be against the law. Yeah, so that's the kind of like maybe the tricky part of the nature of this is that you're going to get, and normally you would get negative 1 times negative 1 is positive 1. But we're more working with the square root times the square root undoes it, and we're left with negative 1. So I know that's hard to understand, but yeah. It's just with this topic here. Yeah. Yeah. If we're going to use this concept here, essentially we want it in relation to powers of I, okay? So negative 1 is what I squared is equal to. So then after you know that this is equal to negative 1, what would I to the power 3 be equal to? You like to say what? So I is equal to the square root of negative 1, and I squared is negative 1. So this would be, what would this equal? Negative 1 times I would be equal to negative I. So there's only I squared and negative 1's in this, okay? So let's look at this one. What would we get here? So this would be negative 1 times negative 1, so that would equal positive 1. Positive 1. Okay, continue calculating powers of I until you reach I to the power 12. So we're going to see a pattern here coming up, okay? So what do you think I to the power 5 would be? So 4 was 1. What would you get here? Okay, so let's write it out. So you would get I, yeah. You would get I. Okay, so how did I get I? Because this was I to the power 4 times a leftover I. What was I to the power 4 equal to? 1. So do you see how I'm getting I out of this? Okay, so I want you to see if you can figure out what's going on here. It is like a higher level thing to think about here. So our I to the power 6. I to the power 6. Okay, what did you get for I to the power 6? Negative 1? Well, the way you can think about this is I squared to the power 3. Do you understand that that's the same thing? And what was I squared again? Negative 1 to the power 3, so it's negative 1. Yeah? So then if that's the case, what would I to the 7 be? Negative I, yeah, negative I. And then, so what's I to the power 8? Huh?
Just 1.
Just 1, yeah. Why is it just 1? Again, if this is I squared to the power 4, do you see this would be the same thing as negative 1 to the power 4? So you'd get positive 1. Okay, keep going. What does that say?
I9.
That says I9? Okay,
I think so.
I9.
Yeah, it's 9. Well, I guess it's not.
Okay, what do you think you get for that one?
So 1 times it would be I. It would just be I. Wait, I get this. Look, this one equals I, and then I times I equals I.
What do you get for I to the power 10 then?
I times negative 1.
Did you get negative 1? Because you need to simplify these i's in order to do any kind of calculations with it, right? So why is it negative 1? This would be I squared to the power 5. So do you see? It would be negative 1 to the power 5. That's how I'm getting negative 1. Okay, how about this one? How about this one? G. I to the power 11.
Oh wait, we're on G.
The next one's just 1, yeah.
Like if it's odd, it's
Okay, so what is the pattern here then? What pattern do you observe in the powers of I? How can this pattern be used to help you calculate I to the power n, where n is any integer? So, for instance, could you figure out I to the power 100 and tell me if it was negative 1, 1, negative I, or I? Let's keep going then. You'll figure it out. Okay, so very good. So again, if it's an even and it's a multiple of 4, that's how we get the 1. If it's an even and it's not a multiple of 4, we get negative 1. If it's an odd and we go down multiples of 4, whatever we're left with, like for instance I to the power 5, it's I to the power 1. That's how we get left with the I to the power 1. If it's, for instance, I to the power 11 and we get rid of multiples of 4, we'd get down to I to the power 3, which would be the negative I. Okay, so now here's an application of more of where we're going with the complex numbers. Italian mathematician Girolamo Cardano, 1501 to 1576, is the first person known to have introduced the complex numbers. He calls these numbers fictitious during his attempts to find solutions to cubic equations in the 16th century. So the way we do this now is we need to figure out with relationship to the square root of negative 1. So for instance, this would be the square root of negative 1 times 3. Do you see? And what was the square root of negative 1 equal to again? It was equal to I. So this would be the square root of 3I. So do you see this one? This would be the square root of 1 times 4. Everybody knows the square root of 4 is 2. So then the square root of 1, negative 1, sorry, is I. So do you see that the square root of negative 4 is actually 2I? Okay. So the square root of minus 20. So this is, I should have actually taught this once we know how to simplify roots, but you'll get a quick lesson pretty fast. So does everybody know that the square root of minus 20, can you think of a perfect square that goes into the square root of 20? 4. So this is the same thing as 4 times 5 times negative 1. So this is going to stretch your, you're going to learn this in a couple lessons anyways. So the square root of 4 can be taken out as a 2, because the square root of 4 is 2, right? The square root of negative 1 can be taken out as a I. And then the square root of 5 we just leave inside because we can't really do much with it. Okay, so the next one, the square root of negative 5, again, this can be the same thing as 5 times negative 1. What can we take out of that? Just, yeah, the square root of negative 1 can be taken out as an I, so this would be just I times the square root of 5. Can you see what this would be? What would the square root of negative 25 be? Okay, so 25 is a perfect square. And that this is time, yeah, it would be 5I. Very good. I heard a bunch of 5 times whatever. Okay, what's a perfect square that goes into negative root 18? Yeah, 9 times 2. Okay, so can anybody think of what can be taken out here? The 9 can be taken out and it becomes a 3. The negative 1 can be taken out and it can be a I. And then we leave the square root of 2 in there. Crazy, hey? Okay. Okay, so do you remember what this was now? I don't know why this is mixed up again. I to the power 6. What was that equal to again? I to the power 25. I to the power 25. That would be I. See, people know how to do this now. Okay. Does that say negative 7?
Yeah.
Oh. Shoot. The only thing is you guys don't know how to handle negative exponents right now. So we're going to come back to C another day. How about I to the power 5? We're going to come back to it. It would be I. Very good. I to the power 30. Negative 1, yes. Okay, and then that's a negative 11, so we're going to leave it. Okay, so now we're going to go more into complex numbers here. A complex number is a number that's a sum of a real number and an imaginary number. So anything in the form a plus bi, where a and b are real numbers and I is the imaginary number. So complex numbers are used in scientific fields, engineering, electromagnetism, quantum physics, applied mathematics, and chaos theory. Complex numbers are added, subtracted, multiplied in similar ways to working with binomials. To simplify complex number expressions, you can combine like terms and apply the various other methods you've learned for working with polynomials. So, for instance, an I plus an I would give you a... Stop it. If I said x plus x is x squared, no. It would be 2x. So it's the same thing like that. I plus I would give you 2i. I times I would give you I squared, which is equal to negative 1. Thank you. Okay, so all these things can have the same operations, and then you just do the last little bit with changing the I squared to a negative 1, etc., etc. Okay, so let's try this. 1 plus 4i plus 3 plus 2i. So what would we get here? We would get 4 plus 6i. So you can't simplify that any more than it is. Okay, the next one is multiplication. Do you see it looks like two binomials? So it's going to be a FOIL situation. Okay, this is really cool when you FOIL complex numbers. Okay, so first we get 4. Outer we get negative 6i. Inner we get plus 6i. But we knew that because this was a difference of two things, right? But anyways, last we get negative I squared. Okay, does everybody see minus 6i and plus 6i will cancel? Now, does anybody know what minus 9i squared would be equal to? Minus 9i squared. Well, what is I squared equal to? Minus 1. And then we have a negative 9. So this would be 4 plus 9, which gives me 13. Isn't that crazy? Yeah? Okay, let's do the next one here. I know, this will stretch your brain. It's kind of cool, though. Okay, this is 2 minus 3i. Subtract this whole thing. And what did we learn when we had polynomials in grade 9, even in the last unit? When you have subtract this whole thing, what was the thing I told you to do? You change the sign. So these brackets don't mean anything. But these brackets means this is minus 1 minus 5i. Now we're going to combine like terms. So what would we get? 1 minus 8i. Because minus 3 and minus 5. Yeah? And could I simplify that anymore? No. Okay. This one's pretty crazy. This one, you may need a little bit more, but you could probably figure it out. Let's see. Does anybody think they know what I root 2 times I root 2 would equal? Yeah, 4i essentially. Sorry, 4i squared, yes. So what does that equal to? No, no, no. What's this equal to? Simplify that. What's I squared equal to? Negative 1. So 4 times negative 1 is negative 4. Now let's put this back. 3 subtract negative 4. So what are we going to get as my answer? Not negative 7. Positive 7. This is the same thing as 3 plus 4, right? Yeah?